PLCs are the brain of modern industrial automation systems. They make precise and fast decisions based on programs they fed with to control automation processes. In our previous video, we have explained about PLC and its components in detail. Please do watch if still not watched. PLCs uses input and output modules to interact with the real world. These modules can be either digital modules, which can processes only binary or digital signals stating on or off condition. Or they can be analog modules, which are capable of processing with continuous range of analog signals. In this video, we are going to understand what a digital and analog signal is, and how it is processed by the PLC's I/O modules. In addition, we are going to know the reason for why the analog signals are modulated in 4 to 20 milliamperes, and why not in 0 to 20 milliamperes. Watch the video fully to get your smart brains updated with knowledge. Welcome to Mr. Smart Engineering. Subscribe and support us with your feedbacks and comments to provide better contents to you. So, let's first understand what a digital and analog signal is. Consider the person who is ready to speak. Until he speaks out, there will be no sound. This silent condition resembles the off state. When he starts speaking at constant level or tone, you can hear a constant sound until he stops speaking. This resembles the on state. So, the signals which have only binary data, that is 0 for off state and 1 for on state, are called as digital signals. Now consider, the same person is going to sing a song for you. When he sings a song, you can hear a sound with wide range of modulation and tones. Electrical signals which are similar to this nature are called as analog signals. They have a continuous wide range of variation in signal during their transmission. Hope this clear about the two type of signals. Now, let's understand how they are processed and detected by the input or output modules of a PLC. Consider a digital input module of a PLC connected with a push button. Let the push button is connected to the positive terminal of a 24-volt DC power supply. Have you noticed a port in the digital module of the PLC named as common? This common port is internally connected with all the input ports and connected externally to the negative terminal of 24-volt DC or ground. Until the push button is pressed, the circuit remains open and there will be no current flow in the open circuit. The absence of current flow through the module is detected as off state and the binary digital signal is set to 0. What happens when the switch is pressed? Due to the potential difference, a small current flow, generally in milliamperes, is generated and it starts flowing through the input port connected in the circuit. The input port detects this constant current flow as on state, and it changes the value in the memory bit of the PLC to 1. This is how a digital input module detects the signal and process. Similar to the input module, let's connect digital output module to 24-volt DC motor. Until the output port closes, the circuit remains open and it remains at off condition. Meanwhile, the PLC processes the input memory and takes the decision in output memory as per the program loaded. The output memory changed to 1 or 0 according to the program. The output module reads the output memory and latch or unlatch the connection at the output circuit. In our case, the output circuit is now closed and will turn on the motor connected. This is how the digital output is processed in output module. Now, let's have a look on analog modules. Unlike digital modules, analog modules are specially designed to work with wide range of analog inputs. In most cases, the analog input devices which are powered externally are connected to the analog input ports of PLCs. These devices are capable of producing electrical signals in form of voltage or current. For an example, let us consider the analog input device connected is a capacitance diaphragm pressure sensors. Until the pressure measurement is started, it produces no current flow with the input module. When the sensor senses the pressure change, it generates output analog signals. This change in voltage is recorded to the PLC memory respective to the input port, either in form of a decimal or hexadecimal values. This value is processed by the CPU for making output decisions. The major disadvantage of voltage-based analog signals generation is they are more prone to noise disruptions. This may affect the precision in measurements made. Hence, to avoid this, the analog signals are usually generated in form of current, says 4 to 20 milliamperes. Here comes the doubt that usually everyone have. Why it is taken from 4 milliamperes and not from 0 milliampere? To understand this, let us consider a scenario where my pressure sensor is going to measure the pressure range of 0 to 10 bar. During initialization, this 0 to 10 bar range is scaled between 4 to 20 milliamperes. This makes the sensor to produce a minor current of about 4 milliamperes, even it is not sensing any pressure and the pressure value is 0. What happens if the sensor is faulty or there is a failure in input supply to the sensor? The sensor not able to produce any minor currents and the input terminal of the PLC now receives 0 milliamperes as a input. So, now we can easily distinguish no measurement state and the faulty state of device by scaling it to 4 to 20 milliamperes. This is the major reason why the analog signals are scaled from 4 milliamperes instead of 0 milliamperes. This remains same for analog output modules too. The analog output modules generate analog signals that can be processed by analog output devices. Hope now you are clear about digital and analog signals. Had doubts in these topics? Feel free to comment and get clarity. Thanks for watching. Don't forget to subscribe, like and share the video.